Hi, welcome back to Fall CS 170. We're on to week 2 of our series. I'm gonna, as I announced last week, I'm gonna break things up into different little clips. So let me start off by going through the announcement I made earlier. I created an announcement to cover CS 170 FAQs, which is frequently asked questions. You can take a look at this. I think the main thing was a very common question I'll just address here is the week 1 resources mentioned learning objectives, vocabulary, and textbook questions. Um, you can go ahead and just look at those from a self-study perspective. Um, you don't need to submit them to myself or to the TAs. It's really for your self-study. But of course, if you do have some challenges answering those questions or you need further clarification, do reach out to the TAs or myself. That's the purpose of those questions, is to make sure you understand the topics. So it's really for yourself. If you don't have any questions, that's great. That means you understand the topics and you understand what you need to know for the learning objectives for week 1. So I'll leave it at that. I think from week to week, I'll probably post more FAQs because I am listening to all of the questions that you're sending to me. And wherever there's some benefit, I'll post it out to the rest of the class. I didn't put it on here, but you might notice you can see Piazza here. Currently, we haven't kicked off using Piazza for the most part, but we probably will be using Piazza more in the future as we get more into assignments that are implementing various things that we're supposed to teach in this class. And there'll probably be some very common questions that it'll be benefiting everyone to see those questions, maybe contribute to the answers and whatnot. So that's really the purpose of Piazza. So you'll probably see more of that in the future. Really the first week, there wasn't much to it. It's just to get everybody set up on Canvas, look at Google Sheets and whatnot. And your TA should be covering that with you. So you can watch out for Piazza in the future. But for now, I'll be posting updates into announcements. So be sure to pay attention to the announcements on Canvas. Okay. So with that, let's go into files. So I'm going to go over here to files. It's going a little bit slow today. Just hanging on me. Come on. All right, let's go to files. And under course information and under the schedule. So let me zoom this up for a little bit. Okay, so you can see here, we're into the second week here. You can see the topics, the readings, what you're supposed to cover in recitation, and basically the assignment will be on numeric conversions. Right? So the numeric conversions is fairly mechanical, and I'll go through various types of numeric conversions a little bit later, as well as that's gonna be covered in your recitation. And there's a whole bunch of material out on the web about how to do the various conversions. So once you pick the process that is most comfortable for you, it's a fairly mechanical type of thing. But I would just say that it's a very commonly tested thing. So it's going to be tested in your midterms. You're going to be tested on your finals for it. So you should get very comfortable with doing these different types of conversions. And I'll be covering that in one of my future clips. So let's go over to here. So this is week 2 resources. So you can notice that it's a bit more than what you had to cover for week 1. And I'm not going to read through all of these. You can see for yourself, just go into the week 2 resources and you'll see all of these different things here. And you see the learning objectives here. So we cover a couple of different things. Like I mentioned here, you have the conversions. So convert numbers, base 2, base 10 to base 16. The reason why you have something called ASCII coding. And then we have a couple other different things going on here, which I'll cover during the lecture. Okay. Notice here, you have learning objectives also. So all of that will be covered as we go. Pretty long list of vocabulary. And notice these links here. You can see all these links for these resources. Like I said, there's a whole ton of resources on how to do these conversions. So just get plenty of practice on it so you can crank it out, because I can pretty much guarantee you these conversions are going to be on your exams or quizzes or quizzes. Okay. Again, you see here in recitation, there'll be some mention. You'll get the practice on these conversions again. Okay. So let me just do a couple little things very quickly to wrap up this first clip, and then I'll move into the other clips as we go. Okay. So we have this introduction or concept, digitizing information. So basically, the whole thing with digital, it just happens to be very common that you look at digital in terms of 0 and 1s, right? And it just kind of stems from how things developed in the past, right? There's no reason why you couldn't, define something as like maybe 4 states instead of 2 states, right? But because of this whole thing where you define things as off and on, 0 and 1, like 2 different states, just from a mechanical standpoint, it worked out easier to work off of a base 2 type of setup. And so that's why you have zeros and ones. So this whole idea of the punch card and using that to process data, right? So basically the person that really drove this is Herman Holleriff. His company rolls up into what is now known as IBM. Okay, so he's an early pioneer in terms of data processing. So he has this whole idea of a punch card. You can see this punch card up here. And basically a hole or no hole translates into a 0 and 1. And if you look at the example that they use in the book, they talked about the 1880 census, which took 8 years to process the data, all by hand. Okay, and there was less people, less questions, and whatnot. So they did the first digitized census in 1890, which they upped the number of questions. Obviously, there was more people, and yet they were able to finish it in a couple years less than what it took to process it manually. And supposedly, it was less cost too. So you have 8 years to process it by hand in 1880. With more questions, more people, they were able to process it 2 years faster using digitized format. And they continue along these lines until you get into later generations where we evolved away from the punch cards. But this is the earliest application of digitizing information to help process large amounts of data. The next idea that we talk about here is the idea of abstraction. So you can see here, you can look at all of the different details, right? You can see this is like the lowest level here pretty much. And you can see this person here doesn't see that level of detail, right? What she cares about is a certain type of interaction. So I kind of maybe give you a basic example. If you look at a car, when you get in the car and you step on the brake, you don't necessarily know what's happening once you step the brake, except that it will slow the car down. Okay, the fact that that brake could be mechanically connected to apply the brakes on the wheels of the car to slow it down, or it could be you press the brake and it sends an electronic signal to the brakes at the wheels to slow the car down. You don't know that, and you don't really care, right? So the idea of abstraction is to move away from the lowest level. If you look at your computer, there's a lot of stuff when you look at the architecture of your computer, how all of the different chips hang together. Then on top of that, there's an operating system that does various different things. And then on top of that, there's some software that you are probably going to be using. And for most of you, you're going to operate at that level of abstraction. Okay, so you don't necessarily care that, I take a file and I drag it to the trash can, how that file magically disappears, right? Or how it gets cleaned up. All you know is that you threw away a file. So that's really what's meant by abstraction, really going up to the highest level to the point where it makes sense for you as a user to interact with something. You don't need to know the lowest level of detail. Okay, so here you talk about the basically the idea of hiding complexity, like I said. Okay, so you can look at a map, right? You can look at something like this on the left hand side, or you can look at something here on the right hand side. So probably for you, if you're trying to get around campus, something like this probably works pretty well, right? By a similar token, you might see some other things like in a city where you look at a subway map or a bus map or whatnot, where you just want to see the route that something is going and what different major stops are, or actually all the stops, right? And that's all you need to know. Maybe, there might be certain key landmarks you want to highlight in there, and that's fine. But you don't need to go down and list every single building, right? In this case, you might list all these different buildings here. You probably don't need to know that. So here, you look at algorithms, okay? So algorithms is basically a series of steps to get something done, okay? So you come up with a process, or in this case, they're saying a method to deliver something at the end, right? So it could be like a recipe. So you could be doing like how to make apple pie, something like that. So you have all the ingredients, and then how are you going to convert those ingredients into a final product? So that's basically what an algorithm is. Very distinct, clear set of steps to deliver a certain output or result. Okay. Okay. So this is stepping into Chapter 7, Digital Information. I'm going to save this for another clip, and I'll wrap it up for now. Thank you.